All right, guys, how you doing? Now, check this out. Report card, right? And the teacher or the parent in the middle is comparing. Yes, we like to compare. There's a data here and a data there. We want to know which is better, which is more spread out. And that's the lesson for today. We will compare the measures of center, and variability. Are you ready? Here we go. So there are two ways to compare data. Data means the number you gathered from your research. What can you use? You can compare the center, this one, the center, all right? You can use the mean, the median, and the mode. We did that in the previous lesson. Now, you can also compare the variability. Variability goes like this. Look at this. A classroom, most of the heights are the same, but in the playground, the heights are different. You want to know how different they are, how different, okay, how varied the different numbers are. And what can you use? You use range, you use mean absolute deviation, or mean to mad ratio. We will explain each of the following. Now, let's start with mean. We did this in the previous lesson. Let's have a quick review. In solving for the mean, what do we do first? We add, okay, and then we divide, and then we get the mean. Remember that? Okay, now for the median, arrange from least to greatest and get the middle number, all right? The middle number. If there are two middle numbers, what do? You add them and divide it by 2 or get the average of it. Now, mode is the most frequent. Most frequent. Okay? So we remember that and there's no need to review that because we did that in the past lesson. Now, we also studied in the past range. Range now could be used to measure variability. How varied is your data or are your data? Now, for example, from 2 to 8, the range is 6, meaning the scores has a range of 6 values in between, right? Suppose in data, let's say data 1, the range is 6, and then there's another data, number 2, the range is 12. So what does it mean? Which is more spread out? Which is more varied? Obviously, the bigger the number, this is greater variability. Greater variability. The numbers are spread out from each other. This one is just 6 values. All right? Okay, we got that. And then the measure of variability, another new one is called the MAD. M-A-D, it means mean absolute deviation. So three important words. I will use the mean. I will use the absolute value, meaning I don't need negative values, just the positive values. And then deviation, how far away is it from the mean? Now, check this out. Suppose you have a data which is the number of apples probably eaten or sold. Okay, so 4 apples for Jennifer, Amelia 3, Noah 3, Daniel 2, and James 5. These are the numbers in our data set. Okay, first let's solve for the mean. How do we get the mean? Add them up and divide it by, add them up and divided by 5, right? So here we go. The average is 3.4. 3.4 is the mean, all right? It's like the middle number, mean. We want to know how far away is 4 from the mean. We want to know how far away is 3 from the mean. We want to know this, how far away is 5 from the mean. We want to know how far away is 2 from the mean. How will you know how far it is? Simply subtract it. So look at the first one. 3.4 minus 4 or 4 minus 3.4, you get a 0.6. That bar means you don't need the negative values, okay? So just do the bigger number minus the smaller number. 3.4 minus 3 or 3 minus 3.4, you get 0.4. 3.4 minus 3 or the opposite, you'll get zero point 0.4. Remember, absolute value means I don't need negative numbers. Just subtract the bigger number minus the smaller number, 1.4. 3.4 minus 5 is 1.6. Okay, So first one, get the mean. Number two, subtract. You call that the absolute deviation. How far away is it from the average? So this is the first, second, third, fourth, and fifth. Next, we will now get the mean of it. We will now average them. So how far is all of this? Add them up. You will get a number, and then you will divide by 5. You will get 0.88. 0.88 is now the MAD. It is the average distance of all the elements in the data set from the mean of the same data set. It's like saying, you know what? Each of the apples are like 0.88 away from the mean. Okay, so MAD. So the third step, remember, is to average. Average. There you go. Now, this is another way to compare variability. Now, check this out. So, let's say there are two report cards, the report card of Noah and the report card of Gabriel. And they solved it already for us. We already have the mean, median, mode, range, and MAD. Good. No need to solve. Now, one way to compare is like this. Check this out. Get the difference between Noah's mean and Gabriel's mean. Okay, let's look at Noah's mean and Gabriel's mean. Noah's mean is 87. Gabriel is that one. Okay, simply subtract them. So let's do the subtraction. 87.17 minus 87 is 0.17. That's the difference. That's the difference. That's the difference. We will use that. Okay, next. We will divide that difference by the MAD. Now, our Noah, we will divide it by the MAD. Okay, check this out. So let's start with Noah. So 0.17 divided by, what do we have? 2.67, 2.67, 0.05. I rounded that so that it won't be a long number. Now, for Gabriel, I will use the same 0.17 divided by 3.22. 3.22. Guess what? I will also get 0.05. If you want to change that to percent, you could move what? Two decimal places to the right. Two decimal places to the right. Both of them are what? Both of them are 5%. 5%. So you could say both of these ratios show that the difference in the means is about 5% of the MAD values. So they're the same, kind of the same. Okay? So there you go. Comparing using another method. Now let's try these Ingenuity problems. Okay? Let's look at this. Julian and Nina are playing a game. Their scores for 5 games are shown in the table below. Julian's score, here you go. Nina's score, here you go. Okay, which statements comparing the medians to the ranges are true? So medians to the range, medians to the range, medians to the range, means and ranges. We don't need the means, we just need the median. Okay, so let's look at the median number first. So the median number, first I arrange this in order. All right, now it's in order. 38 first, 41, then 42, then 46, then 50. Cancel on each side, cancel on each side. The middle number is 42. Okay, next. We want to get the means, just in case this is true, right? So I add it up. I get 217. 217 divided by 5, I have 43.4. Okay, next. I want to get the range. The range is the highest number minus the lowest number. So 50 minus 38 is 12. Okay, are we good? So that's all about Julian. Okay, now let's look at the scores of Nina. So first, let's arrange that from least to greatest. So 27 first, 27 followed by 32, followed by 45, followed by 47, then 49. Now we can get the middle number. There you go. That's the middle number. We're good, right? Next, let's get the average, the means. Add them up, you'll get 200. 200 divided by 5 is 40. So this is the average. Average. Okay. And then the range. The highest number is what? 49 minus 32. 27 rather. 49 minus 27 is 22. Okay. Now let's see. Let's compare the following. The means differ by 1. Look at this versus that. So no, not you. The median differ by 1. 42 and 45, they don't differ by 1. The median differ by 3. 42 and 45. 45 minus 42 is equal to 3. That's true. But the ranges differ by 2. The 12 and the 22 do not differ by 2, not you. So the correct answer, but they differ by what? 22 minus 12 is a 10. So what makes sense? The only one that makes sense is this. And it is correct. The median differ by 3 and the ranges differ by 10. Okay, so for this problem, let's read this. The heights of the starting players on each two basketball teams are shown in the table below. Team A, let's call it the red team. These are the heights of the players. Team B, the blue team. These are the heights of the players, 5 of them. Now, Jacob found out that the mean height team is 71. Are you sure? We will check. And the mean height of team B is 72. We will check. He believes that because team B has a greater mean, it also has a greater mean absolute deviation. So guess what? We will check for mean and mean absolute deviation, which explains Jacob's error. Jacob is wrong somewhere. Let's see what and why. So let's start by solving for the mean. Let's start with team A. Team A, we could see that the total, if I add the data here, team A, if I add 70, 70 plus 72 plus 75 plus 68 plus 70 has a total of 355, then I divide it by 5. So the average is 71. So he is correct. Okay, now let's look at team B. Team B over here. Let's add the values of 71 plus 73 plus 71 plus 72 plus 73 is 360. Divided by 5, I get 72. So, he is correct for these two, 71 and 72. He believes that because Team B has a greater mean, it also has a greater absolute deviation. Oh, MAD. So, we need to solve for MAD. Okay, let's solve for MAD then. Let's start with Team A. Team A, this one, and we know that the average height is 71. So I repeat, subtract 71 on each of the data. Minus 71, minus 71, minus 71. And guess what? You put the absolute value because you don't need a negative value. In short, simply subtract the bigger number minus the smaller number. So 1 for you, 1 for you. 75 minus 1 is 4. 68 minus 71 is a 3. No negatives. 71 minus 70 is a 1. Add 4, 5, 6, 7, 8, 9, 10. A total of 10, right? Because you need to get the average of this. MAD, you get the average of the difference. So 10 divided by 5 is equal to a 2. The MAD is 2. Okay, now let's check the other one. The blue team. For the blue team, okay, what do? We already know the average. The average is 72. So how far away is each core by 72? Remember, subtract from the mean. We already solved for the mean. Okay, and then what do you remember? Put the absolute value, meaning you don't need negative values. In short, bigger number minus smaller number. 72 minus 71 is 1. 73 minus 72 is 1. 72 minus 71 is 1. 72 minus 72 is 0. 73 minus 72 is 1. Our total would be 4, right? So to get the average, of course, 4 divided by 5, you will get 0.8. Okay, so that's the MAD. So you would see that Team A is more spread out because why? More spread out because the MAD is 2 and Team B is nearer than the average, zero point 0.8 away from the average. Okay, so let's look at the generalizations now. One of the means is incorrect. No, both of them are correct. We got it. 71 and 72. Both of the means are incorrect. No, they're both correct. Okay, one of the means is incorrect. No, both of them are correct. So look at this. Both of the means are correct. We got it. And the reasoning is incorrect because check this out. The MAD for team B is okay. Team B MAD is greater than the MAD of team A. So it doesn't follow, right? So our answer here is that it doesn't mean that your average is greater, your MAD is also greater. All right, that's the correct answer. Okay, let's read the next problem. Denise and Sandra are playing a target game. Target game. The object of the game is to get an object close to the center as possible. Each player's score is the number of inches away from the center. Their scores are shown below. So these are the scores of Denise. These are the scores of Sandra. You want to be closer to the center. Okay. Which explains who is winning in the game. Denise is winning because he has a greater mean. Oh, we have to solve for the mean. Okay, so let's solve for the mean. Let's start with Denise. Denise scores. Let's add them up. Our total is 603. Divided by how many? Divided by 5, I will get 120.6. All right, let's look at Sandra's scores. Sandra's scores, let's add them up. Add them up. My total will be 598. Then I divide it by 5. I will get 119.6. All right. Denise is winning because she has a greater Denise is winning because she has a greater mean. Okay? Remember, the closer you are, that's what you want. So, the smaller your number is, the nearer you are to the center. That's what we need. So, this cannot be right. Denise is winning because she is generally closer to the center. 120 is far away from the center. All right? Okay, it is based on inches. They're counting the inches away. So you're farther away from the center. That can be the answer. Sandra is winning because she has a greater mean. Okay, is Sandra's mean greater than Denise? No, it's not. What else? Sandra is winning because she is generally closer to the center. Okay, so the correct answer is this one. Okay, the fourth one. The smaller the number is, the closer you are in the center because they're counting the number of inches. Okay, next. Nia, let's read the problem. Nia recorded her science and math scores. The measures of center and variation for each scores are shown below. Oh, thank God, it's already there. All the data I need are already there. Okay, which inferences can be made when analyzing the data summary of the table? Select three possible answers. Okay, number one, her mean science score is higher than her mean score in math. Mean science is higher than mean in math. Correct. That makes sense. She prefers science over math. She prefers science over math. She likes science more than math. Does that, the greater it is, does it mean you like it better? No, sometimes I like the subject, but my grade isn't that good. So that doesn't, that's not supported by data. There is more variation in her math scores. Okay, variation, use MAD or the range. Okay, see, math is greater than the science. So this makes sense, correct? All right, her science scores are more spread out. Are the science scores spread out? No. Look at the range for spread out. We're looking at this one. They're lesser than the math. So that doesn't make sense. Her median scores are the same for each subject. Let's look at the median scores. The median is 60 and 60. Yes, they're the same. So also that makes sense. So our correct answers are this, and this. Okay, so that's it. So remember guys, results is equal to action plus motivation. Good luck.